topics to be covered in today's session is, I will cover remainder theorem advanced model, remainders theorem advanced model, not the basic remainder theorem application, advanced models, remainder theorem advanced models, how to find the integral solution for linear equations in seconds, how to find the integral solutions for linear equations using the Anil Nair classes approach. Then we will discuss another concept of how to simplify algebra problems and get the answers very fast. How to simplify algebra problems. Last but not least, how to solve symmetric function based questions. Symmetric function based questions. These 4 topics, close to about 2 hours it will take to cover all the 4 topics present in it. Please take a paper and a pen and keep writing all the important concepts in the way I am discussing. Remainder theorem advanced model, integral solutions for linear equations, how to do it in a conceptual method. Then I will tell you, if Anil Nair classes students are there, how you should solve it in seconds, how to simplify algebra problems, and how to solve symmetric function problems, which is extremely important for SSC and other examinations. Now, let us write first concept 1. Concept 1. Remainder theorem. Remainder theorem. Remainder theorem. Let me come from the basics. What is a remainder theorem? When a polynomial function is divided by x minus a, remainder is nothing but p of a. Remainder is nothing but p of a. When a polynomial function is divided by x plus a, when a polynomial function is divided by x plus a, wherever x is there, substitute minus a. What is p of x? P of x is nothing but a polynomial function. P of x is nothing but a polynomial function. What is a polynomial function? A polynomial function will be of the form a0 plus a1x plus a2x square plus a3x cube and so on up to an x power n. These the definition of a polynomial function. Polynomial function will be of this form. One simple example. For example, remainder 1, x square minus 7x plus 12 divided by x minus 1. Divided by x minus 1. If a polynomial function is divided by x minus a, wherever x is there, substitute a. Wherever x is there, substitute 1. 1 square minus 7 into 1 plus 12. So this will become 13 minus 7, which is nothing but 6. 13 minus 7, which is nothing but 6. It's a simple, everybody knows this remainder theorem, but I am going to solve remainder theorem advanced level problems. Another important note, when I divide 4 by 2, 4 is perfectly divisible by 2, so the remainder will be 0. That means 2 is a factor of 4. That means 2 is a factor of 4. 2 is a factor of 4. If the remainder is 0, that means the denominator is a factor of numerator. Similarly, if a polynomial function is divided by another expression and if I get the remainder 0, that means q of x is nothing but a factor of p of x. Q of x is nothing but a factor of p of x. So same thing what I did it in number system, same thing is also valid in algebraic expression. If I get the remainder, denominator expression will become a factor of the numerator. P of x divided by q of x. Q of x is a factor of p of x. This is an important thing. Now let us take one question. I am just starting with the basics. Slowly I will increase the level of difficulty. Remainder 1. X square minus ax plus 7 divided by x minus 2 is 0. Find a. Find a. Remainder 1, x square minus ax plus 7 when divided by x minus 2. Remainder is 0, find a. Or this question can also be asked like this. If x minus 2 is a factor of, x square minus ax plus 7, x minus 2 is a factor of x square minus ax plus 7, find a. Both are same questions. So what you have to do? Because x minus 2 is a factor of this number, remainder has become 0. So one is a mathematical terminology, another is an English statement. So wherever x is there, substitute 2. So 2 square minus a into 2 plus 7 equivalent to 0. So 4 minus 2a plus 7 equivalent to 0. So this will become 11 equivalent to 2a. A is nothing but 11 by 2. You can also find the value of a variable if you know it. One is what we did. What is a remainder theorem? Remainder theorem helps us in determining the remainder when a function divides the another function. That is the first concept we discussed. What is the second concept we discussed? What happens when the remainder is 0? When the remainder is 0, denominator expression becomes a factor of the numerator expression. Second point, I hope it is clear. Third point, these are all the basic level problems which you will find it in the regular textbook. Now advanced level. Now listen carefully. Note. Suppose if a number is divided by 3. I will get, what are all the reminders? What I will get? I will get the reminders 0, 1, 2. 0, 1, 2. A number could be perfectly divisible by 3. A number can give a remainder 1. A number can give a remainder 2. A number when divided by 3, I will get the reminders 0, 1, 2. I will replace a number with a polynomial function. If a polynomial function is divided by a quadratic expression is of the form ax square plus bx plus c. If it is divided by 3, I will get the remainder 0, 1, 2. If a polynomial function is divided by degree 2, answer will be either degree 0 or degree 1. You cannot get a cubic expression when you divide by quadratic expression. So any function which is of the form degree 0 or degree 1 is nothing but px plus q. If p is 0, it will get degree 0. If p is not 0, I will get degree 1. I hope the idea is clear. Whenever a polynomial function is divided by a quadratic, remainder will be of the form linear. Similarly, whenever any polynomial function is divided by cubic, ax cube plus bx square plus cx plus d, if it is divided by 3, answer will be a quadratic. Px square plus qx plus r. Px square plus qx plus r. Extremely important concept. When a polynomial function is divided by an expression of degree n, when a polynomial function is divided by an expression of degree n, answer generic expression is expression of degree n minus 1. Expression of degree n minus 1. Please make a note of this extremely important concept. Very important concept. When you divide a number by 3, the highest possible remainder is 2, which is 1 less than the denominator. When I divide a number by degree 2, answer highest possible is degree 1, which is 1 less than degree 2. When a polynomial is divided by degree 3, highest possible is degree 2, which is 1 less than degree 3. When I divide a polynomial expression with an expression of degree n, answer will be an expression of degree n minus 1. Answer will be an expression of degree n minus 1. Please make a note of it. When a polynomial function is divided by an expression of degree n, answer will be an expression of degree n minus 1. All the problems whatever I am solving are based upon this type. I hope till here concept is clear. Now I will take a lot of questions so that you will understand in detail what is the entire key point. When a polynomial function is divided by a quadratic expression, answer will be 1 degree less than quadratic. So these are nothing but px plus q. These are nothing but px plus q. Idea clear? Degree 2, worst case remainder is degree 1. Degree 3, worst case remainder is degree 2. Now this is the concept. Now let us take a first question. I hope the concept is clear. First question. Remainder 1. Remainder 1 x power 100 minus 2x power 99 plus x power 50 minus 2x power 49 plus x square plus x plus 1 divided by x minus 1 x minus 2. Solution. Listen carefully. Whenever any polynomial function is divided by a quadratic expression, answer is nothing but a linear expression, px plus q. Till here it is clear. Now let us take an example. Suppose 13 is there. I divide by 5. 5 2s are 10. Remainder is 3. So 13 is nothing but 5 into 2 plus 3. 5 into 2 plus 3. I hope it is clear. Which we call this one as dividend. 5 we call it as a divisor. 2 we call it as quotient. And 3 we call it as a remainder. Same thing. Suppose, so that means instead of 13, this is the value. Dividend is x power 100 minus 2x power 99 plus x power 50 minus 2x power 49 plus x square plus x plus 1. This is a dividend. Dividend equivalent to divisor is nothing but x minus 1 into x minus 2. How much it is getting divided we don't know, which is q of x. But we know definitely that when a polynomial function is divided by quadratic, remainder will be degree 1, which is px plus q. You should know how to write this expression. Only when you can write this expression like this, now the answer will be very clear. If I put x equivalent to 1 power 100 1 minus 2 plus 1 power 51 minus 2 plus 1 square 1 plus 1 minus 1 0. These are nothing but p plus q. P plus q is nothing but minus 2 is minus 4. 1 4 cancel. So p plus q is nothing but 1. Similarly, if I take x value 2, so this is nothing but 2 power 100 minus 2 into 2 power 100 minus 2 power 100 plus 2 power 50 minus 2 into 2 power 49 2 power 50 2 square plus 2 plus 1 7. All these will get cancelled. These is nothing but 2p plus q. 2p plus q is 7. P plus q is 1. 2p plus q is 7. Simplification. P is nothing but minus 6. Q is nothing but minus 6 plus q is 1. Q is nothing but minus 7. So answer is nothing but minus 6x plus 7. Minus 6x plus 7. I hope the idea is clear. A very beautiful question on reminders, which seems to be very difficult if you do not know the concept that when a polynomial expression is divided by a quadratic, answer is nothing but a linear. So because I know that it is linear, I took it as px plus q. Dividend equivalent to divisor into quotient plus remainder. I substituted x equivalent to 1. I got p plus q equivalent to 1. I substituted x equivalent to 2. I got 2p plus q equivalent to 7. If I subtracted p is 6, if p is 6, if I take 2p, I think I did a small mistake, 2p minus p is 6, p is 6, these minus 5, sorry sir, it is 6x minus 5, I did a small calculation mistake, 6x minus 5, 2p minus p is p, 7 minus 1 is 6, p is 6, 6 plus q is 1, q is minus 5, so p value 6, q value minus 5, answer is px plus q, which is nothing but 6x minus 5. Idea clear? First problem, any doubt? I am sure there is no doubt if you know this concept. 6x minus 5. There is a small correction which I made it. These not 6. These small, these p equivalent to 6 and q equivalent to minus 5. So answer is 6x minus 5. First problem clear. Second problem. Second one. Another same model. Already the best thing about this question is, already he gave in the question that remainder is ax plus b. So just now we discussed solution. X power 100 is divided by x minus 1 into x minus 2. I don't know what is q of x. But I know that the remainder is ax plus b. So this is nothing but, dividend is nothing but divisor into quotient, x minus 1, x minus 2 into q of x plus ax plus b. Same thing, substitute x equivalent to 1. 1 equivalent to 1 minus 1, 0, which is a plus b. Substitute x equivalent to 2. 2 power 100 equivalent to 2 minus 2, it is 0, it is 2a plus b. So if I subtract it, 2a minus a is a is 2 power 100 minus 1. So 1 equivalent to a plus b. So this will become 1 equivalent to 2 power 800 minus 1 plus b. So b is nothing but 2 minus 2 power 100. b is nothing but 2 minus 2 power 100. So answer is nothing but ax plus b, which is nothing but 2 power 100 minus 1 into x plus 2 minus 2 power 100. I hope the idea is clear. When a polynomial expression is divided by a quadratic expression, answer will be a remainder will be of the form linear. So what I did here, I used here the concept of dividend equivalent to divisor into quotient plus remainder. Dividend equivalent to divisor into quotient plus remainder. Then I substituted x equivalent to 1. Then I substituted x equivalent to 2. I got two equations. I subtracted a, I got 2 power 100 minus 1. b, I got 2 minus 2 power 100. I substituted in ax plus b. Idea clear? Third one. Another interesting question. Most of the students will leave this question thinking that it is a difficult question. The question is remainder 1, 81, because it is 3 power 20 is there. This is nothing but, this can be written as remainder 1, 81 is nothing but 3 power 4 power 21. 27 is 3 cube power 21. 9 is nothing but 3 square power 21 plus 3 power 21 plus 1 divided by 3 power 20 plus 1. 3 power 20 plus 1. This can be written as 84 can be written as 3 power 20 power 4 into 3 power 4. 63 can be written as 3 power 20 power 3 into 3 power 3. 42 can be written as 3 power 20 power 2 into 3 square. 3 power 21 can be written as 3 power 20 into 3 power 1 plus 1 divided by 3 power 20 plus 1. Seems like a difficult question. No, actually it is easy. Consider, let 3 power 20 equivalent to x. So the entire expression will become 81 x power 4, 27 x cube, 9 x square plus 3x plus 1 divided by x plus 1, wherever x is there, what I have to substitute? Minus 1. 81 into minus 1 power 4, 27 into minus 1 whole cube, 9 into minus 1 square, plus 3 into minus 1 plus 1. Whatever the answer that you will get it, that itself is the answer. Instead of giving you the variables, he gave such kind of exponent values just to create a fear in you. Nothing to fear. Wherever 3 power 20 is there, take x value. So 81 is 3 power 4 power 21, 27 is 3 cube, 9 is 3 square. So 3 power 20 power 4. This entire question is translated to this value. 81 x power 4 plus 27 x cube plus 9x square plus 3x plus 1 divided by x plus 1. Wherever x is there, substitute minus 1. I hope you got the idea. Next one. Third one. Fourth question. Now, let us read one by one. A polynomial function when divided by x minus 1. There is a polynomial function, it seems. When that polynomial function, when it is divided by x minus 1, I got a remainder 2. That means wherever x is there, if I substitute 1, I got a remainder 2. Whenever there is a polynomial function p of x, when I divide by x minus 2, I got a remainder 1. That means wherever x is there, if I substitute 2, I got the remainder as 1. What is the question? What is the remainder when polynomial function is divided by x minus 1, x minus 2? I know that x minus 1 into x minus 2 is a quadratic. When a polynomial function is divided by quadratic, answer is nothing but a linear. So ax plus b. Dividend equivalent to divisor into quotient plus remainder. X minus 1 into x minus 2 into q of x plus ax plus b. Easily you will get the answer. I will tell you another shortcut approach after this method. If I put x equivalent to 1, p of 1 equivalent to a plus b, p of 1 is nothing but 2. If I put x equivalent to 2, p of 2 is nothing but 2a plus b. It is nothing but 1. If I subtract a equivalent to minus 1, b equivalent to 3. B equivalent to 3. Minus 1 and 3. Answer is nothing but. Find the, what is the question that he is asking? Right? Find the not the polynomial function. Find the remainder when the polynomial function. In fact, you can also find the polynomial function. Right? So, it is ax plus b. Answer is minus x plus 3. Answer is minus x plus 3. Remainder is of the form minus x plus 3. I hope it is clear. Minus x plus 3. So, p of x is nothing but x minus 1 into x minus 2 into some quotient minus x plus 3. That will also become the polynomial function where q of x needs to be determined. I hope it is clear, right? Idea is clear. Answer is minus x plus 3. Just change the question to find the remainder when polynomial function is divided by x minus 1 and x minus 2. Minus x plus 3. Now, this method in the exam you should not do it. This is a time consuming method. Time consuming method. How to get the answer in seconds? How to get the answer in seconds? Very advanced level question. You can reduce your time if you know method 2. What is method 2? We will see. Method 2. Method 2, if you see here, a number when divided by 7 gives a remainder 1. A number when divided by 8 gives a remainder 2. A number when divided by 7, it gives a remainder 1. A number when divided by 8, it gives a remainder 2. Positive reminders are not same. What is the negative remainder? Suppose 13 when divided by 5, 5 2s are 10, positive remainder is 3, negative remainder is minus 2. From where you got minus 2? 3 minus 5 is minus 2. 1 minus 7 is minus 6. 2 minus 8 is minus 6. I hope it is clear. Minus 2 is nothing but 3 minus 5 is minus 2. So 1 minus 7 is minus 6. 2 minus 8 is minus 6. So the number form is nothing but the number should be divisible by 7 and 8. LCM of 7 and 8. Negative remainder is the same. So LCM of 7 and 8 into k minus 6. This is something which most of you already knew it in number system. Now see here, how am I using it in algebra? Instead of n, it is a polynomial function. If it is divided by x minus 1, positive remainder is 2. When it is divided by x minus 2, positive remainder is 1. What is the negative remainder? 1 minus 7 is minus 6. 2 minus 8 is minus 6. 2 minus of x minus 1, which is minus x plus 3. 1 minus of x minus 2, which is nothing but minus x plus 3. Directly we got the answer minus x plus 3. What will be the form of p of x? P of x is nothing but x minus 1 into x minus 2 into q of x minus x plus 3. This is exactly which we got, which is the polynomial function. If I want the remainder, it is minus x plus 3. What you are doing in number system, when the negative remainders are same, the same thing can also be applied. Same thing can also be applied in algebra. In algebra, if positive reminders are 2 and 1, negative reminders is 2 minus of x plus 1 minus x plus 3, 1 minus of x minus 2, which is minus x plus 3. So the reminders are same. So answer for this question, if the remainder is asked, it is minus x plus 3. If the polynomial function is asked, whatever I wrote in the box, that will be the polynomial function. I hope the idea is very clear. Remainder theorem, basics to an intermediate to an advanced level concept.